In this video, we'll learn about dividing fractions using common denominators. Use the diagrams given to represent the division problem and find the quotient. So for our first problem, we're given 9/2 divided by 1/2. So let's start by answering or writing the copies of language. So this is asking, how many copies of 1/2 are in 9/2? So to use the number line, notice it's labeled from 0 to 5, and all of the whole numbers are labeled, and there are tick marks halfway between, which will represent the 1/2. So let's label these. So notice I've labeled these in halves, so if we consider just these tick marks, and we start at 0, which is 0/2, each tick mark can be labeled in increasing order by adding 1/2. So 1/2, 2/2, 3/2, 4/2, etc. Now notice 9/2 is right here. Plot that point. So when we use the number line, we're thinking of the length of this segment from 0 to 9/2 is 9/2. And we want to see how many 1/2 are in it. So let's count the number of 1/2. If we go from 0 to 1/2, that's 1 1/2. This is the second 1/2. Continuing, we have 3, 4 1/2, 5 1/2, 6, 7, 8, and 9. So there are 9 1/2 in 9/2. Okay, so that's similar to thinking of 9/2 as 9 copies of 1/2. So that's consistent. So the symbolic representation, we'd say 9/2 divided by 1/2 is 9. Okay. Notice, and we'll get to this soon, that if we divide 9 by 1, the result is 9, and 2 divided by 2 is 1. And dividing across is consistent with our results and our answer. Okay, and this is probably the easiest way to divide fractions when we have common denominators. So we're looking specifically at these types now. Okay, so looking at the next one, we have 8/5 divided by 2/5. So our copies of language is how many copies of 2/5 are in 8/5. Okay, so here's our number line. It goes from 0 to 2, and each whole number or unit from 0 to 1 is broken into 5 pieces. 1 to 2 is broken into 5 equal pieces. So let's start by labeling these. So now I've labeled this number line from 0 to 2. Instead of labeling by whole numbers, I labeled by fifths. So we have 0/5, 1/5, 2/5, 3/5, etc. And our dividend is 8/5, so I plotted that point. Okay. So now let's highlight this segment from 0 to 8/5 is 8/5, and we want to find how many 2/5 are in 8/5. So, unlike the last example, we were just counting by ones. Here we have, or I think 1/2. Here we're counting by fifths, but we're counting by 2/5. So this is 1 copy of 2/5. From 2/5 to 4/5 is another 2/5. Okay, so we're going 2 tick marks to get an additional 2/5 until we get to 8/5. So there are 4 copies of 2/5 and 8/5. So our symbolic representation, if we divide 8/5 by 2/5, the result is 4. And again, notice when we had the same denominator, okay, we could almost ignore the denominators here and just think, well, we have 8 units. They're size 1/5, but there are 8 of them. We want to see how many copies of 2 of those size units are in each one. So it's equivalent to dividing 8 by 2. And if we divided the denominators, we'd have 5 divided by 5 is 1, and our result is 4. And that's consistent with what we found in the diagram. Let's look at the next one. So this next one's a little bit different because the denominators aren't exactly the same. Okay, we have 18/4 and 3/2, so they're different. Okay, now we're going to use the denominators given, but before we do that, let's just notice if we wrote 3/2 with a denominator of 4, that'd be multiplying the numerator and denominator by 2. This problem is equivalent to 8/4 divided by 6/4. So if our previous results hold, 18 divided by 6 is 3, 4 divided by 4 is 1. We should get a result of 3. Okay, so let's see what happens using the original numbers. And our copies of language is how many copies of 3/2 are in 18/4. Okay, so here's our number line. Okay, we have the whole numbers labeled, and each whole number is broken into 4 equal pieces. So let's label this. So notice I labeled these by fourths, starting at 0. It's 0 over 4. And then each next tick mark is 1/4 more. So we have 0/4, 1/4, 2/4, 3/4, 1 is 4/4. That makes sense. 4 divided by 4 is 1, etc., all the way up to 18/4. Okay. Now we want to find copies of 3/2. Okay. So these are labeled in fourths. So let's just use a different color. How about blue? Okay. And notice halfway between, so 2/4 here. So 0, this is 1/2, 2/2, so every 2/4 is 1/2. So I'm just going to break them up this way, and then we can count 3 of these blue units to find the copies of 3/2. So I know there's a lot going on here. Let me change colors. How about light blue? So if we start at 0 and we want to find our first copy of 3/2, we start at 0. There's 1/2, 2/2, 3/2. Okay, and notice this is 1 1/2. That's equivalent to 3/2. Okay, starting here, 1, 2, 3/2. So 1, 2, 3/2. There's our second copy of 3/2. And finally, 1, 2, 3/2. Here's our third copy of 3/2. So labeling these above, we have 1, 2, 3 copies of 3/2 in 18/4. Okay. Symbolically, 18/4 divided by 3/2. Well, we just found that result is 3. Okay. We already saw up here, if we change 3/2 to 6/4, our result was 3. 3 over 1, which is 3. And let's just take note that if we divide the numerators and the denominators in the original form, 18 divided by 3 is 6, and 4 divided by 2 is 2. And 6/2 reduces to 3 over 1, or 6 divided by 2 equals 3. So that's consistent with what we've seen in all of these problems. Okay, so even sometimes when we don't have common denominators, if we have this special situation where dividing the numerators and denominators gives us whole numbers, this is the easiest way to divide fractions. Okay, just to give you an idea of why we'll need another way, if we had something like 17/5 divided by 9/11. Okay, notice dividing the numerators would give us 17 divided by 9 over 5 divided by 11. Let's say ew. Okay, that's not making this problem any more simple. Okay, and we're going to learn a way to deal with this. Okay, but when we use the common denominator method, we can see why this representation works. So what patterns do you observe in problems A through C? And we developed that. You can divide the numerators and divide the denominators to find the quotient. And this, in fact, is always true, okay? But again, it's not always what you want to do, because you may get something like this. But in these cases, if you have the same common denominator, it's just going to be dividing the numerators, which is simple, okay? And if you have a special case where dividing the denominators, even if they're not equal, gives you a whole number, that would be an easier way to do this as well.